So this is the third video of Lesson B, so we'll call it BC, C being the third letter of the alphabet, bottom of page 13, talking about surface area. Alright, so surface area, when we're talking about something like a funny shaped figure like this, and we'll put dotted lines to show that there are actually sides, but you can't see them, so they're hidden. So we've got an object like that, and this is 4, this is 5, this is 3, and this is 6, and they're showing this being a right angle, and this over here then would be a right angle. And they're asking to find the surface area. What they're asking you here is, what is the area of this triangle, of this triangle, of this bottom, of the back here, and of this slanted front. We're going to add them all together. So you're finding the area of all of the sides, and then you're adding them all together. So let's look at this one at a time. We have one side here and one side here, two triangles. So that's two pieces that we have. So we have two triangles. We have a base, this bottom right here that it's sitting on. So we have one base, and we have a back, this back part here. So one back, and then finally we have this part right here, the slanted part that goes down. So we'll just call it one slant. This is just for me to make sure I see that I'm getting all the sides here. So I know my triangle is 1/2 base times height, which in this case, let's get this out of the way a little bit, 1/2 times 3 times 4. And I know I have two of those. So I've got two of those that I'm going to be doing. So let's go ahead and do that. 1/2 times 3 times 4 is going to be 6. And I have two of them. So I have an area of 12 when it comes to both of those triangles. So I put a box around the 12 knowing that that's one of the numbers I'm going to add. I also have my base, and I said my base is this bottom part right here, and it's 3 times 6, so that's 18. And so I know I'm going to add that. My back, I'll go ahead and do in color in green here, is my length, which in this case, my length of that back is 6. It's the 6 this way, or 6 from here to here. And my height is 4. So that's going to be 6 times 4, so that's going to be 24. Box that, because that's done. And then my slant. And let's do my slant in kind of a pinkish color. My slant is going to be this right here. And that slant is 6, this one right there. And now I have to find out how far it is from here to here. And that is 5. So that's going to be 30. So if I add 30 plus 24 plus 18 plus 12, everything in my boxes, I should get the right answer if I did everything correctly. So 12 plus 8 plus 24 plus 30 equals 84. And that would be the area of that. And the area then would be, in this case, centimeters squared. Okay, so whenever you're dealing with area, it's going to be square inches, square centimeters, square meters, that kind of thing. Alright, let's look at the next one. It has to do with a right cylinder. And it says that our right cylinder has a top. Let's do that in the pink here. And that is 4. And then we have the cylinder. And we say, let's make a little dotted circle at the bottom, and it's 10 high. And they're interested in the surface area. Now, if this were a pop can, it means that they're interested in not only Well, they're interested in how much metal it's going to take, how much aluminum it's going to take to make this pop can. So it's going to be aluminum for the sides, and it's going to be aluminum for the top and aluminum for the base. So we are going to have to figure all this out. Now, one of the things that's easy is we can figure out our area of our top and bottom. It's going to be the same size, so we just have to figure out the area of the top and double it, and that'll give us the area of the top and the bottom. So the area of our circle, notice how I draw kind of a little circle down here to show what I'm doing here, is pi r squared, which in this case is going to be 4 squared, 16 pi, and since we have two of them, we're going to multiply that by 2. Okay, so that'll give us the area of the top and bottom. Now, this part right here that we're measuring, if we were to take that pop can and cut, I'll use white here, and cut this right down the center, and we were to lay it out, it would lay out like this, wouldn't it? It would fold out to be a rectangle. And I know that that rectangle from here to here is 10, and I know this length right here would be the same as this length right here when we unroll it. So that is the circumference. So I'd have to find the circumference of the circle, which is 2 pi r, and once I find that circumference, then 2 pi, and we said the radius was 4, so that would give us 8 pi, and in this case we're going to multiply the 8 times 3.14. That would give us 25.12 as far as our length is concerned. So our area then of this whole thing would be 10 times 25.12, which would be 251.2. So we're going to take that, 251.2, and add the area of our circles on the top and the bottom, which would be 100.48 when we multiply this out. So we take the 100.48 and we take our 251.2, add those all together, and we get 351.68 for our surface area of that right cylinder.